Hello, my name is Shannon Ricci. I'm a PhD candidate at NC State, and today I'll be sharing my work as an NC Space Grant and NCC Grant Fellow, an assessment of visitation trends at North Carolina artificial reefs using high-resolution satellite imagery. The main motivation of this work is to answer the question, how can we assess visitation at artificial reef sites? Currently, the state of North Carolina participates in the Marine Recreational Information Program, which conducts boat ramp interviews with recreational fishermen to get information on where and when they were fishing and what their target species was. In addition to MRIP surveys or other interviews, reef managers can also conduct on-water observations to physically observe boaters on the reef and record information on what they see, how many people, size of their vessel, and what activity they might be doing, diving or fishing. These are the traditional methods to assess visitation, and while they can provide detailed information about the activities of recreational boaters, these methods are often limited when it comes to spatial and temporal coverage, and when it comes to the surveys, they are often biased by low response rates. As is the case in many disciplines, the growing availability of satellite imagery products enables researchers to explore new ways to answer their questions. When it comes to monitoring coastal environments, satellite imagery may be able to provide increased spatial and temporal information than traditional methods allow. The main objective of this project was to use satellite imagery to generate a visitation time series at 4 North Carolina artificial reef sites. I used PlanetScope 3-band imagery with 3-meter pixel resolution available through Planet's education and research program, and focused on all available cloud-free imagery from 2019. The white dots you can see in this image are boats at the reef site. I also looked at additional information, including the type of material used in each reef, to get a sense of what might be driving spatial patterns. In North Carolina, artificial reefs are made up of a lot of different materials, including things like sunken vessels, seen by this orange polygon here, concrete, shown by the pink polygons, and other materials, including aircraft, pipes, and metal. Our results were compared to those from the previously mentioned MRIP surveys. We also acquired AIS tracking data. AIS, or Automated Identification System, provides point location information of vessels equipped with a transmitter. Converting the points into tracks, we can see where and when the boats were traveling through the reef site and use it to verify our detections. So how do we count boats in the imagery? A big part of this project was developing a boat detection model that could be used to detect both stationary and moving boats. Stationary boats can be seen in these orange squares and moving in this purple square. I had over 1,000 examples for each of these classes to train the model. After the model was trained, I deployed it on the entire time series of imagery from 2019 to get point locations for every detection. Using these detections from 4 pilot artificial reef sites, we can then assess temporal and spatial visitation patterns and compare this approach to information gained from MRIP surveys and AIS detections. Looking at the temporal patterns, we see that overall detections were highest in spring and summer months, most likely coinciding with increased fishing opportunities for target species or warmer water conditions for recreational diving. Of the 4 pilot sites we studied, AR 315 off the coast of Atlantic Beach and AR 425 off of Oak Island were the most visited sites. AR 160 off of Oregon Inlet was the least visited site. If we compare the number of boat detections from the satellite data, shown here on the right, to the number of boaters who reported visiting each reef site here on the left, we can see that first there are similar patterns with higher visitation in spring and summer in both approaches. Second, it is important to note that there are overall fewer observations from the MRIP survey, both spatially and temporally. Particularly for AR 370 off Wrights Frill Beach, there was only 1 month where a person reported going to that site, and from our imagery, we see that this is an often visited location. Temporally, interviews were not conducted in the winter months, November through February, and while we observed few detections in those months, it highlights how a combined approach may help fill those gaps. One of the most interesting potential applications of this approach is the spatial information we can get. Here's a map of the 2019 boat detections at Artificial Reef 315 off Atlantic Beach, overlaid with the reef material types and locations. We can see that detections are highly clustered around the sunken vessel at this site. I will be doing spatial analyses to look at which materials are most visited across all sites. This could provide valuable information to the artificial reef program as they plan to add new reefs or reef material and need to weigh the costs and function of the target materials. While this work is still in its early stages, I believe that an approach combining passive methods like satellite imagery or even underwater acoustic monitoring, which is part of my future research goals, with traditional methods like surveys and on-water observations may provide a more complete picture of reef use.